Welcome to Power Hungry. The year is 2040. I wake up feeling tremendously refreshed because the brainwave sensors in my pillow have determined the perfect moment to wake me up so I'd be energized throughout my day. I grab my iPhone 31 and realize that I just have a few minutes before I have to get to my big meeting at work. I throw on some clothes and head over to the delivery portal, where an hour earlier, Starbucks and Instacart have delivered everything I need for breakfast. I grab my hot coffee and sit on the sofa, and sensing my presence, the AI-powered TV turns itself on. Although she's retired 15 years ago, it uses my favorite avatar of Nora O'Donnell to give me a quick synopsis of everything I need to know for my day moving forward. It covers everything in just a couple of minutes and lets me know when it's time to go. As I get up, I head towards the garage and walk through the mudroom. And there I see my home companion robot carrying the laundry to the bedroom. He gives me a nod just to not acknowledge my existence and then heads off towards his work. He's the best thing I've ever gotten. He does laundry, he does the floors, he makes the beds, but he is the worst cook I've ever seen. After that, I go to the garage and get ready to get in my car and marvel at all the power-consumptive appliances that are in my garage. First of all, there's my lawnmower, my robot lawnmower that opens the garage door every day, goes out and inspects my lawn and makes it look like a golf green. The next thing is my robot trash can, actually one of my favorites. Every Wednesday, rain or shine, it takes itself down to the curb and returns itself when the trash has been collected. And then I have 2,000-mile range EVs. Battery technology's come quite a long way. I jump in the back of my car and I give it directions to get to work and sit back for a nice 40-minute drive where I can get some work done. I pull up my laptop and I realize that all of my robot agents have taken care of most of my work. I am the head of robotics for my factory, and in fact, it's the very factory that makes those robotic trash cans. As I head to work, I see that my robot agents have actually negotiated a 17% discount on parts, and they've done a great job reducing my need for staff. And in fact, speaking of reducing staff, I'm a little nervous about this upcoming meeting. When I get to the factory, I see that business is booming. We have electric autonomous trucks charging up like crazy, and they're either dropping off raw materials for the factory or they're taking our finished products to distribution. They only sit at the dock for about an hour while they get loaded and unloaded, and so the charging has to take place very rapidly. I walk into the warehouse, and there are robotic forklifts loading and unloading these trucks. They work about twice as fast as a human being. They do have to go down for charging for quite some time, but they are a real boon to the workforce. Seeing that that's going okay, I head into the main assembly area where the robots are doing their job, assembling our robot trash cans. I used to have someone here 24/7 to repair the robots, but since I've taught them to repair themselves, we really don't need anybody, and my department is really just down to me. I guess it's time to go see the boss, and although I'm sweating a little bit, I walk in his office, and as always, he greets me warmly. We talk about the kids, we talk about our vacations, and then he says to me, "Jeff, I have a serious matter to discuss with you, but before we get to it, I want to give you some context of how we got here." If you remember, Jeff, back in 2025, 2026, all the talk was about generative AI. It was only a year or two old, and the big talk was that generative AI data centers were going to be taking up all of the electricity in the country. Everybody was kind of worried. As a matter of fact, there were many projections that said that although it took 150 years to get the electricity consumption to the level it was in 2025, that it would double by the year 2040. And of course, when there's a limited supply of a product like electricity, the price goes up as demand goes up. And it wasn't just the electric commodity. It was also the price of transmission and distribution, because a lot more infrastructure needed to be built to carry the extra electricity. And that was provided there was enough generation, and that was a problem too. At the time, the generation lead times just to get the equipment were tremendous. Gas generation was 7 years minimum. Small modular nuclear hadn't even really been delivered yet, but it was 10 years out. And large conventional nuclear was 15 years out. This was bad enough and created a substantial energy gap. But what made it worse was politics. There was no neighborhood that wanted new high-tension lines, even fewer that wanted a new substation, and even fewer that wanted a nuclear plant in their neighborhood. Aside from that, there was the problem of money. Electric rates had already gone up tremendously. The public nor the politicians had the stomach to provide more money for more infrastructure and put it on the bills. It was just too expensive. We were running into a roadblock. So what we needed was something like the interstate highway system. That was too big for any state to do individually. The feds provided a tremendous amount of money for it, and it proved to be one of the principal drivers of our economy for the last 60 or 70 years. It was a tremendous project. It was time for us to build that infrastructure on a national level. And so the Energy Security Act of 2030 was passed. And it was looking for a way to make power available on a national scale. And what was decided is that nuclear reactors would be built on the 10 largest military bases in the country. It was actually great because the federal government had the money. In fact, it was a small part of the military budget, much smaller than the Iran war, and it gave us energy security. It was almost the perfect solution because when you think about it, the military was used to working with nuclear power plants. They had nuclear submarines and nuclear aircraft carriers for quite a long time. The military base could also protect this asset from terrorist attacks or other attacks. Furthermore, in the case of a national disaster, let's say a hurricane, or let's say we had a grid failure, at least the military bases would be operational, giving them the ability to help out in the case of any kind of disaster we had. Finally, the best part was the power that would have been used by the military base would be freed up for the civilian grid, bringing power back to the cities and back to the areas that needed it the most. It seemed like the perfect plan, and the state governments couldn't stand in the way because this was federal land. And all that worked great, but the people who did the projections didn't think about physical AI at the time. Physical AI is everything that we see in this factory. It's that robot lawnmower. It's all the things that have AI chips in them that can't work with the data center because if they lose the connection, it could be dangerous. All the things in this factory are physical AI. And so this created an even bigger load. Let me give you an example. Anything that's creating value, any type of factory or anything else that's creating value, mixes labor, energy, raw materials, and creates an output. If it's an Italian restaurant, you take pasta and ground meat as the raw materials. You take the labor of the chef, and you take the electricity to cook it, and you make lasagna. But in the modern world, in the world we live in the world like our plant, it's different because the labor content has shrunk tremendously, but the electricity content that has taken its place has grown tremendously. So all the mechanization you see is taking power in addition to the data centers. And so it's a different paradigm now. In fact, it's changed even the way we think about our cities. In the old days, cities were there to support large working populations. That's where your workers came from. That was your critical mass. The city was there to provide the infrastructure to support not only the business with raw materials, but the workers themselves that had to provide everything that was needed for a large mass of workers. However, the new cities that we need now need to provide cheap electricity. That's the primary input. Also cheap land to build on, and also access to lots of data in real time. This changes everything. This is a satellite map of the United States at night showing power consumption in the year 2026. But because electricity prices had jumped up so much, and because so much electricity was required to build things, to have factories, and to make the intellectual output that we need, the Northeast was unable to compete in many ways. And what we needed was new cities. And so the states that wanted people like Montana and Wyoming made land available to build new cities with nuclear power plants at their core, allowing them to drive big data centers, allowing them to drive factories, and all the things we needed at a low enough cost for the United States to be economically competitive. And these cities were actually funded by the hyperscalers, the people like Google, the people like Meta, where it gave them a chance to have a good place for their workers, a great new place to run massive data centers all in one spot. This is an example of a city that's built in Wyoming at the foot of the Grand Tetons. It's called Amazonia, and I'll let you think about who probably sponsored it. It has everything you need, plenty of cheap power, plenty of cheap land, recreational activities, clean air, great schools, no crime, and it is a fantastic place to live. So Jeff, the reason I brought you here was to tell you that because of the things we just spoke about, we're going to be closing our plant in the Northeast. We're going to be moving it to Amazonia. At this point, I'm really sweating. He said, but Jeff, don't worry, because we're going to ask you to be the manager of the entire plant at double your current salary. Welcome to your bright future. The year is 2026. I wake up feeling exhausted, but hoping that my dreams become reality. Thank you.